Chang'e-5 mission discovers significant water-rich mineral in the moon's soil. There is water on the moon, and scientists have just confirmed where a lot of it may be hiding. A mineral in moon dust collected by China's Chang'e-5 lander and ferried to Earth was recently found to contain so much water it makes up 41% of its weight. The mineral is similar to novo-grablenovite, which was only identified a few years ago in basaltic rock from Russia's Kamchatka Peninsula. Both the lunar and terrestrial versions have the chemical formula NH4MgCl3 6H2O and have similar crystalline structures. Given that we can study novo-grablenovite right here on Earth, the discovery of an almost identical mineral on the moon can give us some clues about where lunar water is hiding and how it got there, as well as the history of lunar H2O, water that is. The origin, presence, and distribution of water on the moon remains something of a mystery. It's something scientists want to figure out because where the moon's moisture came from and where it is now is an important component of the history of the Earth-Moon system. In addition, knowing where water is lurking has significance for future lunar exploration missions, since humans need water for survival. Water has been found in older lunar samples before, trapped in tiny glass beads that are produced when surface material melts and forms what are known as spherules. Detections of water signals in the spectrum of light reflected from the moon's surface suggest there's plenty more up there somewhere. One prevailing notion is that water is bound up in minerals that comprise the lunar regolith. Previous studies, however, have suggested that the hydrogen and oxygen bound up in moon dirt can be in the form of other hydroxyl molecules, compounds made up of hydrogen and oxygen in proportions different from that of water. When it landed on the moon in December 2020, though Chang'e-5 made a breakthrough, the first in situ detection of what appeared to be water in a boulder on the moon. It was unclear, though, whether the detection was actually molecular water or another hydroxyl molecule. That required a closer analysis than what a robotic lander could provide. And now humans on Earth, led by physicists Xifeng Jin and Munan Hao of the Chinese Academy of Sciences, have performed that analysis, subjecting samples sent to Earth by the Chang'e-5 mission to X-ray crystal diffraction and chemical isotope analysis techniques to determine whether the lunar regolith contains water or something else. Their efforts revealed the presence of molecular water with the mineral NH4MgCl3 6H2O containing up to 6 water crystals. Novo-grablenovite rarely forms on Earth, emerging from the interaction of hot basalt with volcanic gases that are rich in water and ammonia. The lunar mineral is not quite the same. The chlorine isotope found within it has a different composition to terrestrial chlorine isotopes, but its formation mechanism is likely to be quite similar. This suggests a moon source of both water and ammonia existed when volcanic activity was active in the moon's past. Thermodynamic analysis shows that the lower limit of water content in the lunar volcanic gas at the time was comparable to that of the driest volcano on Earth today, Lengai volcano, the Chinese Academy of Science writes in a statement. This reveals a complex history of lunar volcanic degassing, which is of great significance for exploring the evolution of the moon. The discovery also suggests a previously unknown source of water on the moon, hydrated salts. This is much more stable than water ice, suggesting that it may be available even on areas of the moon frequently bathed in sunlight, reducing our future possible reliance on water ice sequestered deep in shadowed craters at the lunar poles. The team's findings have been published in Nature Astronomy, and this is by Michelle Starr on Science Alert. Please leave your comments. Thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.